All right, Math 2, here we go. We got kind of a long one today. We got lesson 9.2.1, quadratic applications with inequalities. All right, so during a field trip to an amusement park, Thor notices that a portion of the Gold Digger's Gulch roller coaster is shaped like a parabola. There we go. We got a little parabola there. The track looks like it goes underground to this tunnel, and a car speeds towards the tunnel from 300 feet above the ground and then reemerges 100 feet to the right horizontally, so it comes out of the ground over here. All right, so basically on this problem, we got to realize that this is probably going to be our y-axis right here. So there's our y-axis on that side, and the ground will probably be our x-axis over here. So that means that when we're underground, our y values will be negative. When we're above ground, our y values are going to be positive. Now we have some points of interest here. We've got a vertex down here, but I don't know exactly where that point is. It's probably going to be right in between, since these are, it's definitely going to be right in between because these are the intercepts. So right here, that would be the axis of symmetry. So it looks like this is 50 and then 50 more. So it looks like that vertex has an x value of 50, but I got a problem. I don't know what the y value is for this one. Over here, I've got my y-intercept. It looks like the y-intercept should be at 0, 300. And I've got my two x-intercepts. So my x-intercepts, I got one of them right here, so we go over 50 right there. That's the point 50, 0. Because that's when we're going, the right about to go underground, so we got a height of 0 right there. And over here I've got my other x-intercept, and that would be at 150, 0. Because I've gone 50, then I'm going to go 100 more. Okay, so we want to write an equation for this one. But when we're writing this equation, probably vertex form is not our best bet to go for because we don't know how far down this is going to go here. So instead, since I do have my x-intercepts, I think I should probably instead use factored form. So with factored form, we're just going to go f of x equals, my two intercepts are 50 and 150. So remember, in factored form, we would do x minus 50 and x minus 150. Now, this isn't the full equation because I don't know what my a value over here is going to be. So I kind of need to figure out what would the a value be for this one. Well, so far I've got an equation. If the a value is 1, like the parent function, if it's 1, then I should be able to use this point here, plug in zeros, and then get 300. So let's see what would I get when I plug in zeros. So if I plug in 0 here and here, I get negative 50 times negative 150. So multiplying those two together, I get positive 7,500. Well, that's not 300. So that means my a value needs to be something that makes this smaller than 7,500. So what do we multiply 7,500 by to get 300? Well, you can do this a couple ways. You can just take 300 and divide by 7,500. You can do that. Or you can work through it and see what I can reduce this by. Either way that you do it, you get 0.02, which is the same thing as 1 over 20, or 0.04, which is the same thing as 1 over 25. So that needs to be our a value. Now if I take 7,500 and multiply by 25, I do finally get 300 as my height here. So now I know that I have a working model for this parabola that we have here. So sometimes we have to look at what do I need to add, what multiplier do I need to add to make this fit the y-intercept over here after plugging in these zeros. And that's what we needed to do to pull this 7,500 and make it smaller so that it was 300 instead. We need to multiply by 1 over 25, which is the same thing as dividing by 25. All right, so now we're going to write an inequality to show when the roller coaster is underground. So underground, the y values are negative or smaller than 0. So my equation for this one would be 1 over 25 times x minus 50 times x minus 150. It has to be smaller than, so less than 0. That's when it's going to be underground. Now, we've never solved anything like this, but what I can see over here, I can see that the underground portion goes from 50 to 150 right there. That's the underground portion. That's the x values when we're underground. So my x values are between two numbers. They're between 50 and they're between 150. And so we would say less than right here. So if you read this one backwards, we are saying that x is greater than 50 because that's going this direction here, greater than 50. And then reading over this way, x is less than 150. That's this direction. So those are the x values when our y values are down here. The other one says write an inequality to show when it's above ground. Well, above ground, 25. We've got x minus 50, x minus 150. Above ground, our y values are greater than 0. So here's our new equation as an inequality when we're above ground. Now, just looking at this over here, I can see when it's above ground, I'm going to need to use this area and this area above ground. So instead of having a conjunction here where they're going towards each other, I have a disjunction where they're going away from each other. So the solving that we can do from here just by looking at the graph is that x is less than 50. So before we had x was greater than 50, and now we have x is less than 50, or we've got x is greater than 150. That's this section over here where it's greater than 150. So when it's a disjunction, they're going away from each other. We usually use an or in between them. Now, we didn't solve those algebraically, but if we were to solve them algebraically, what we would do is we would solve this as if it was factored form, which it is. We would set these both equal to 0. So we do x minus 50 equals 0. And we do x minus 150 equals 0. And so solving this, we'd get 50 and 150. But these are not, this is what it would be if it is an equation, but it's not an equation, it's an inequality. And what we would have to do at this point is think of it as being a number line where I've got 50 here and I've got 150 here. And what I have is 3 regions in my graph where I can test these 3 regions to see if they make this into a true statement. So for instance, I might plug in, let's see, what number would be down over here? Maybe 0. So I might plug in 0 and see if that makes a true statement. What number would be in between here? Maybe like 100 or something. So I might test 100. What number over here might I test for this section? Maybe I would test 200. And I'd plug it into these equations and see if they make a true statement. So like if I plugged in 0, I have 0 and 0. 50 times 150, negative 50 times negative 150. That'd be positive 7,500 times 1 over 25. And we'd get a big number over here. And of course, it'd be greater than 50. We'd say, oh, this section does work. So my solutions are over here. If I plugged in 100, I'd get 50 times negative 50. I'd get a negative number over here, basically. And a negative number is not going to be greater than 0. So this section wouldn't work. And if I were to plug in 200 over here, I'd get 150. And 200 minus 150 is 50. So 150 times 50, again, I get 7,500 something. And that is greater than 0. So I'd find out this section works. So that's how we might do it like algebraically if we're solving this one. Later on, we're not going to have graphs, and we're going to need to solve it algebraically by testing areas like that. All right, next problem. San Francisco is well known for its fog. I got a lot of spelling errors in this one, sorry. I did it late last night and I was sleepy. Very thick, low-lying clouds that hide its hills. One foggy day, Hannah's practicing kicking a football. Once she kicked, wow, I really messed up this one. The football so high that it disappears into the fog. The height h of the ball in feet can be represented at time t in this equation right here. I missed the parenthesis there. Wow. All right, the ball disappeared when it was 40 feet high. All right, so we've got our equation here. The ball disappeared when it's 40 feet high. So we want to write an inequality that represents when the ball was not visible. So that's when it goes over 40 feet. So our equation would be negative 16t squared plus 64t. And then it's when the ball is over 40 feet, so greater than 40 feet. And that would be my inequality that I would need to solve. Now, I don't have a nice graph with this one, so I'm going to have to do this algebraically to solve it. So in order to do it algebraically, I always need 0 on one side of my equation. So I'm going to subtract 40 first. All right, and so when I subtract 40, I get negative 16t squared plus 64t minus 40 is greater than 0. All right, so there's my quadratic equation. I need to solve it now. Now, if it factors, I can put it into factored form and then solve using the principle of zero products. I've done this one already. It doesn't factor. But I do notice that 16, 64, and 40, I can make these numbers smaller to make them a little bit easier to work with by factoring out a number because a number goes into all of these. So the number that goes into 16, 64, and 40 is 8. And I'm going to go ahead and factor out a negative 8 because I usually like my t to the seconds to be positive. So let's factor out a negative 8. So I factor out a negative 8. Remember, when you factor out a negative, then you can just divide all these by that number. So this divided by negative 8 gives me 2t to the second. This divided by negative 8 gives me negative 8t. This divided by negative 8 gives me negative 5. All right, now I've got something a little bit more manageable that I can solve. Now, if we were to check to see if it factors, what we would do, this is positive. So what we would do is we would do that where you do the diamond and the box method. Remember, with the diamond method, you go, okay, this times this, that's 10t squared. And then it should be adding up to negative 8t. But the problem with this is there are no factors of 10 that add up to negative 8. So we're in a problem. We can't use factored form. So if it doesn't factor, your other option is to probably use the quadratic formula. So let's go ahead and use the quadratic formula really fast to solve what t could be right here. So I would do t equals negative b, so negative 8. Plus or minus the square root of b squared, so negative 8 squared, minus 4 times a, which is 2, times c, which is 5, all over 2a. All right, oops, 2a. A is 2. So I'm going to clean this up. This is positive 8. This is 64. Negative 4 times 2 is negative 8. Negative 8 times 5 is negative 8 times 5 is negative 40. And then 2 times 2 is 4. All right, I can clean it up a little bit more. I get 8 plus or minus the square root. This is 64 minus 40, that's 24 over 4. All right, so there's two answers in there, 8 plus root 24 over 4 and 8 minus root 24 over 4. Now, root 24 is approximately, calculator, 4.9. So this is 8 plus or minus 4.9. So let's do 8 plus 4.9. 8 plus 4.9 ends up being 12.9 over 4. And then 8 minus 4.9 ends up being 3.1 over 4. And then if I divide both of those by 4, let's just call the first one about 3.2. And the second one is about 8, or 0.8, sorry. All right, so these are my x-intercepts. These are where I'm going to set up a number line, and it's going to give me 3 sections. Here I've got 0.8, and then my other boundary point is 3.2. And now I've got 3 areas to test, and I need to find 3 points in those areas. Let's look at this first area here. Maybe I would use 0. And then I need something in between 0.8 and 3.2, so maybe I would test 2, because that's a number in between there. For this section, maybe I would test 4. Okay, so what I'm going to do is I'm going to plug in 0, 2, and 4 into this equation to see what I get. All right, let's plug in 0. This is the easiest one. I get 0, I get 0, I end up with 5. 5 times negative 8. So for this section, I've got 5 times negative 8, which is negative 40. And negative 40, is that greater than 0? No. So my answer is not in that section. Let's jump over to 2. If I plug in 2, 2 squared is 4. And then 4 times 2 is 8. And then over here, I've got negative 8 times 2, so that's negative 16. So right now, I've got 8 minus 16, so that's negative 8. Negative 8 plus 5 is negative 3. And then negative 3 times negative 8 is 24. So for this section, I get 24 is greater than 0. Now that does work. So my answer could be in that section. Well, it is in that section. Last section that we would check is this last section over here with a 4. If I plug in a 4, 4 squared is 16. 2 times 16 is 32. I'm going to have to write this down. I'm going to forget the numbers. So that's 32. 4 times this gives me negative 8 times 4 gives me negative 32. And then plus 5. Oh, this is easy. So this gives me negative 8. This makes 0. That's 5. So negative 8 times 5. What did I miss there? I did something wrong. Oh, no, this is right. So I end up with negative 40. And negative 40 is not greater than 0. So my answer is not in that section. So now I found the answer that my section is in. My answer is between 0.8 and 3.2. So this is like this one up here where it was in between 2 numbers. So we write it as a conjunction. And our final answer would be 0.8 is less than x less than 3.2. What are we saying here? We're saying that when she kicks the ball into the air from 0.8 seconds until 3.2 seconds, we're not going to see the ball. So it goes up in the air. This is when it's over 40 feet in the sky. So there's this section in here between these 2 times when the ball is above the clouds and we can't see it. What's the maximum height of the ball? Well, to find the maximum height of the ball, we would look at the original equation up here. So we would do h of t. Let me move around real quick so that the lights don't turn off. Okay, I moved around. So we would take the original equation and we would find out where the 2 x-intercepts are. We did not find the x-intercepts over here, remember, because they were equal to 40. We were just finding out when it's going to be above the clouds. So what we would do over here instead is we're going to find the actual x-intercepts. So that would mean that I'm going to go ahead and factor it because the x-intercepts are when this is equal to 0. If I factor out a negative 16t, I would be left with t minus 4. So now we would use the principle of zero products. We'd say negative 16t equals 0 and t minus 4 equals 0. So this gives me t equals 0 and t equals 4. So what I just found are the x-intercepts. So we're looking at this problem here, and we've got an x-intercept of 0. The ball goes up into the sky, comes back at 4 seconds. So my vertex has to be right in between there, because that's where my axis of symmetry is. So my axis of symmetry is 2. So that's the x value of my vertex. Now all I have to do is find the y value to find my vertex up here. So if I plug in 2 into this equation, I should be able to find the y value, and that would be the maximum height of the ball, because that's the vertex. So plugging in 2 into this equation, h of 2, if I do negative 16 times 2 squared plus 64 times 2, this is 4. And this number over here is 128. And negative 16 times 4, what is that, negative 64? So I get it, 64. So my vertex is at 264, so there's my maximum height. Remember, the first number is the time, 2 seconds, and then at 2 seconds, I would be 64 feet in the air. Sorry that you couldn't see all that, all my lovely work that I was doing there. Right, that was a lot. There's still a second page, but this should be faster when we do the second page. All right, second page. Consider this inequality here. Okay, we're going to start by finding the boundary points. The boundary points are the y-intercepts. So I need 0 on one side of the equation. So my first step is to write this as x squared plus 2x. I'm going to subtract 4 from both sides, and I get negative 3, less than 0. Okay, so this one does factor what multiplies to give me negative 3, but adds to give me 2. That would be positive 3 and negative 1. So x plus 3 times x minus 1. All right, and now I would use the principle of zero products and set these equal to 0. X plus 3 equals 0. X minus 1 equals 0. It looks like I get x equals negative 3 and x equals positive 1 over there. So now that I've got that, I can now set up my 3 regions. So here's my 3 regions right here. So negative 3 was my smallest number. 1 was my biggest number. And I've got 3 regions, below negative 3, between these 2 numbers, and above 1. So I have to pick some numbers in these regions. I like to pick 0 when I can. So 0 would test this middle region. Maybe I would use negative 4 to test this region over there. And maybe I would use like 2 to test this region over here. So I'm going to test those 3 regions. Let's test the first region. Now I'm going to use factored form because it's going to be easier. Let's plug in negative 4 here. Negative 4 would give me negative 1 for that first parenthesis. Negative 4 here would give me negative 5, less than 0. So negative 1 times negative 5 is positive 5. 5 is not less than 0, so this is not part of my answer region. Test the next section. Plug in 0 to both of these. So if I plug in 0, I get 3 times negative 1, less than 0. So I get negative 3 is less than 0. Yes, that does work. So this region is part of my solution set. Now I'm going to test 2. If I plug in 2 here, I get 5. If I plug in 2 here, I get 1. And this gives me 5 is less than 0. No, it's not. So my answer is not in that region. So my answer is between negative 3 and 1. So my final answer for this one would be negative 3, less than x less than 1. So it's all the numbers, all the x values in between -3 and 1 are my solutions. Okay, so that's how we solve it algebraically. We've got a couple problems to solve algebraically here. Okay, the first one is nice. It factors for us. What multiplies to give me -12 but adds to give me 1? That would be 4 and -3. So this factors into x plus 4 and x minus 3. Set them equal to 0. So this finds our boundary points. I get -4 and +3. There's my boundary points. And I would set up the line. Here I've got -4 down here somewhere. I've got +3 over here somewhere. And now I need to have something to test. I'm going to test -5. I'm going to test 0, looks like a good one. And I'm going to test +4. So there's the 3 regions that I test. Let's start with -5. -5 over here gives me -1. -5 here gives me -8. And I get +8 is less than 0. That is not true. So this region does not work. Let's try 0. If I plug in 0 to these two, I get 4 and -3. So 4 times -3, I get -12. And is -12 less than 0? Yes, it is. So my answer is in that region. Test 4. 4 plus 4 is 8. 4 minus 3 is 1. So I get 8 is less than 0. That is not true. So this is not part of my answer. So again, my answer is in this middle region right there. So my final answer is going to be -4 less than x less than 3. Last one, I need to get 0 by itself. I need to get 0 by itself. 7 by itself. No. Yeah, I need to get 0 on this side. Anyways, we're going to subtract 7. Let's just do that. All right, so I'm going to subtract 7 from both sides. And I get -2x squared plus 10x minus 7 is greater than or equal to 0. Okay, so for this one, we're going to factor out a negative. I don't like my x squared to be negative, so I'm going to factor out a negative. I'm left with 2x squared plus 10x, minus 10x. I factored out a negative. I have to change the signs. Plus 7. All right, let's see if this one factors. So remember, we multiplied these two numbers right here. So that gives me 14x squared. And here I've got -10x. So I asked myself, is there anything that multiplies to give me 14 but adds to give me 10? No, there is not, sadly. So for this one, we would have to go ahead and do the, do the quadratic formula. So I'm going to skip this because we're already at 28 minutes. So let's move on to the last one. So this one, we'd have to do the quadratic formula, very similar to how we did it on this page right there. So we'd end up doing the quadratic formula to solve that one. That's kind of a mean problem to give you guys, but whatever. Right? Nothing multiplies to give us 14. No, it's 2 and 7. That's 9. That doesn't work. All right, last one. If we've got an absolute value, hopefully you learned last year that you can set up 2 inequalities here, where you do x minus 2 is greater than 7, and then our other inequality would be x minus 2. We flip the sign, and then we make it -7. So these ones are a little bit different. We can still test, but this one we can do a little bit easier. So we're going to add 2 to both sides and get x is greater than 7. And then over here, we're going to add 2 to both sides and get x is less than -5. All right, so if I'm looking at a graph where -5's over here and 7's over here, I've already got these kind of worked out. It says x is greater than 7. That's going this direction. This one says x is less than -5. That's going in this direction. So that's different from these. It says my answer should be here and here. And we could test it. I mean, we could plug in -6 over here. We could plug in 0 here. We could plug in 8 over here. Let's plug in negative 6 real fast. If I plug in negative 6, I get negative 8 in here. Absolute value is positive 8. 8 is greater than 7. That side does work. If I plug in 0, I get negative 2, which makes a positive 2. That is not greater than 7. That doesn't work. If I plug in 8 over here, 8 minus 2, 8 minus 2 is 6, and 6 is not greater than. Wait a second. Did I do something wrong? Oh, yeah, I did something wrong. This is 9. I was rushing. So this was supposed to be 9, so we should be plugging in, instead, we should plug in 10. So this is what happens when I rush through the end of it. All right, let's plug in 10. 10 minus 2 is 8, and 8 is greater than 7. So this section does work when we plug it in there. All right, so since it's a disjunction like this, we would just write our answer as x is less than negative 5, or, since they're going in opposite directions, x is greater than 9. So similar way to do it, we can test out the regions in either method. There you go. That's all the math that I got for you. Math hard. See you later. Bye-bye.